Hey guys, welcome back. My name is Miss Danielson here with another lesson on factorizing expressions. This is our second lesson on factorizing expressions, so I hope you join us for our first lesson where we were factorizing expressions with a number factor. Today we're going to be looking at factorizing expressions when we have a variable as our common factor. Let's get started. First of all, you should definitely know how to expand brackets. And if you don't, I'm linking that lesson again down in the description box below, along with our first lesson on factorizing expressions. But I'm just going to go through this very quickly now as a quick reminder. When we expand brackets, we multiply the term that is touching the brackets from the outside by all of the terms inside. So here I'm going to do 5 times 4, which is 20, 5 times 2x, which is 10x, and there you have it. In our second example, we have a number and variable term out front. So we're going to multiply number by number and letter by letter, multiplying that through. 2a times 4b, that'll be 8ab. Next, 2a times negative 2ab will be negative 4a squared b. For example 3, we're multiplying again a number and variable combination term by the terms inside the bracket. That's 14a squared b times a will be 14a cubed b. And then we're doing 14a squared b times 3b. That will be plus 42a squared b squared. Now, if you have any trouble understanding how these brackets expanded out, you're going to have a look at our previous lesson on expanding brackets. Otherwise, let's keep going. When we're factorizing an expression where we don't have a common number factor, as we've got here, 3, 18, and 7 do not have a common factor apart from 1. But if I factored out the 1, the values inside the brackets would stay the same. When we divide any value by 1, the value stays the same. So forget about our numbers. Look for a common factor, which is a variable. As always, we'll consider all terms of the expression, so 3a, negative 18ab, and negative 7a squared, and look for the highest common factor. This includes the powers of these factors. So when I'm looking at these letters, a, ab, and a squared, I see that all terms have a as a common factor. One of these terms has a squared. Don't let that confuse you. That just means a times a. So if I write the highest common factor outside the bracket, that is a, and I find the factor pairs inside the brackets, I'm looking for the values that a must multiply by to give the original terms. So a times what makes 3a? Or another way to think of that is 3a divided by a leaves me with 3 inside the bracket. So 3 is the factor pair that goes with a to make 3a. For the second term, if I factor out the a, that is if I divide negative 18ab by a, I will be left with negative 18b. Don't forget the sign. The sign is very important. Here it's a minus sign because I'm dividing a negative term by a positive variable. Negative divided by positive is negative, so negative 18b. The third term, negative 7a squared, means negative 7 times a times another a. So if I factor out this a, that is if I divide this term by a, I will still have negative 7a. Think about multiplying that back through. If I did a times negative 7a, I would get negative 7 times a times another a times a is a squared. Right, don't forget to check that your factorized expression has the correct number of terms inside the bracket. If my original expression had 3 terms, I should have 3 terms inside the bracket. My second check is to mentally expand out that bracket. So to do the a times the 3 makes the 3a, the a times the minus 18b makes minus 18ab, and the a times the minus 7a gives me minus 7a squared. There's one last check that we have to remember to do, and that's to make sure that we've factorized fully. Make sure that the terms inside the bracket don't have any other common factor apart from 1. 3 and 18b could both divide by 3, but 7a could not. So that's it, we're done. A was our highest common factor, so we factored that fully. Let's go on to some examples. If you feel comfortable with that, go ahead and hit pause and try these for yourself. Otherwise, I'm going to keep working through them with you. So for example A, 27x, 8xy, 5xyz. Looking at those numbers, there is no common factor apart from 1. So let's forget about the numbers and look at all three terms for maybe a common variable factor. X, xy, xyz. Notice that all three terms involve x, so we could factor x out of all three terms. So I'll write my highest common factor, that's the x, outside the bracket, and inside the bracket I write the factor pairs. 27x divided by x is 27. 8xy divided by x would leave me with just the 8 and the y. But don't forget this is positive 8xy divided by a positive x. So the term inside the bracket should be led by a plus sign. Plus 8y. My third term, positive 5xyz divided by positive x, will leave me with a positive term, and that would be plus 5yz. Next example, look carefully at the numbers first. 6, 13, and 14 do not have a common factor other than 1. So let's look at our letters. And this is getting a bit challenging here. I notice that all three terms have the letters U and V in them, but I need to pay attention to the powers as well. I see some of the terms have U squared, but not all of them. I see some of the terms have V squared, but not all of them. So the highest power of each of these letters that all three terms have is just 1. So U, V. I'll set up my highest common factor, UV, outside my brackets, and inside the bracket goes my factor pair. If I divide 6UV by UV, I'll have 6 inside my bracket. If I divide negative 13UV squared by UV, I'll have negative, the number is clear, I have nothing to divide that number by, so negative 13, and the letters U divided by U will cancel that U out. V squared divided by V will cancel out one of those V's, so that'll be negative 13V. And my last term, positive 14U squared V divided by UV, that will leave the 14 as positive 14 because there's no number to divide that number by, but the letter U squared is getting divided by U, which will cancel out one of those U's, and the V is getting divided by V. Any value divided by itself becomes 1, so that will cancel out the V as well. That'll be plus 14U. Last example, look at all four terms, look at the numbers. Do they have a common factor? 12 and 4 could both divide by 4, but 7 and 9 couldn't. 9 and 12 could both divide by 3, but 7 and 4 couldn't. So the numbers do not have a common factor for all four terms. So let's look at the letters now. All four terms have the common factor a squared b. The highest possible power of b that we can put is 1 because the second term and third term and fourth term only have b, not b squared. So my highest common factor is out front, and inside the bracket for the first term, if I factored out a squared, that a squared gets cancelled. If I factored out b, one of those b's gets cancelled. So I still have 7b. For the second term, positive 12a squared bc divided by a squared b. It's still going to be positive because a positive divided by a positive will stay positive, so that's plus 12. The a squared cancels, the b cancels, and we're left with a c. So plus 12c. My third term, negative 4a squared bc divided by a squared b. A negative term divided by a positive will still be negative. The negative 4 value is not going to change because I've got no number to divide the 4 by, so that's negative 4. But the a squared will get cancelled with the a squared, the b will get cancelled with the b, and the c will remain, so that's negative 4c. And my last term, positive 9a squared bc divided by positive a squared b, a positive divided by positive, leaves me with a positive term. That'll be positive 9, the a squared cancel, the b will cancel, and I'll just have the c squared left. So that's positive 9c squared. Again, check that I have the right number of terms inside the bracket, check that it would multiply out correctly, and check that there's no common factor inside the bracket apart from 1. And as I was checking that there were the right number of terms inside the bracket and that there's no common factor for those 4 terms inside the bracket, I did notice something, and I wonder if you did as well. I see that 3 of these terms have c in them, but not the first term, so c is not a common factor for these 3 terms. However, 2 of these terms are just some number of c, 12c minus 4c. They're like terms, so they could be simplified. 12c take away 4c is 8c, which leaves me with an expression which is factorized, but I've only got 3 terms inside the bracket. Now that's not a problem so long as the original expression could also have been simplified. And 12a squared bc minus 4a squared bc, they're also like terms. They could also be grouped together. 12 minus 4 is 8. So that would also be 8a squared bc. Now I've got an original expression which has been simplified by grouping like terms. And when I factorize that, I still have the common factor a squared b. I factored that out of all 3 terms, and I have a factorized expression with 3 terms inside the brackets, matching the 3 terms of my original expression. It doesn't matter if you simplify before you factorize or simplify after you factorize, but our answer should always be in the simplest form. Now we should be ready to get on some practice. So have a look over these examples. See that they're very similar to the examples that we just went through. Go ahead and copy the questions, work out your answers, remember those checks. Go ahead and hit pause now and try that, and hit play when you're ready to take up your answers. I hope you've had a chance to hit pause, because here come your answers. For question A, B, C, D, E, F, G, H, I, J. Now, how did you manage with all of those powers there? I hope you did okay. If there's any problems or any confusion, please leave me a comment in the comment box down below so I can clarify that for you. Otherwise, if it went well for you, I think you might be ready for our last lesson of this series, that is factorizing expressions with number and variable factors. Until next time, keep practicing, and I'll see you soon. Bye!